In this short video, I'm going to demonstrate how to put together a basic camera projection setup using Nuke. So you can see I've already got a script open here with some nodes and various other elements contained within it. And I've already got my viewer connected up to this graphic. Okay, this graphic shows the nodes required to set up a camera projection in Nuke, and I want to quickly go over these. So I'll just zoom in fact I'll tab to maximise my node graph so that we can see this in large scale. So we can see that I've got basically 5 nodes here. I've got a 6th node, which is the scanline render, which I'll come back to later. So I've got this checkerboard which is serving as my matte painting. So the matte painting is the 2D image to be projected. It can be a single image, it can be broken up into several layers, as in like in Photoshop. It could also be a combination of several matte paintings, for example, to be projected from different projection cameras. As I said, in this example I'm just going to be using a very simple checkerboard. Next along I have my shot camera. This is the camera that will be used to render the final shot to be used as part of a film sequence, for example. And this is configured to meet the cinematic requirements of the shot through its various optical and animation controls. Next to this we have our projection camera. Now this is the camera that won't be seen by the audience. The audience will have no relationship with this camera. The purpose of this is purely and simply to project the matte painting onto a geometric surface or surfaces. This is usually, but not always, derived from the position of the shot camera, taken for example from an optimum frame. We'll see this in a few moments. But essentially any animation of the optical or the transformational parameters from the shot camera would be removed, so this camera is fixed and static. Next along I have my geometry. In this case I'm using a flat 2D planar card, but this is essentially the 3D surface on which the matte painting will be projected. This is critical to creating the illusion of parallax. At its simplest level this can be a flat 2D planar surface, for example a card as in this case, placed at different positions in 3D space. At its most complex it could be a 3D environment consisting of complex and intricate polygon based modelling. And finally we have the projection shader. In Nuke this is known as the Project 3D node, and this is the conduit that connects the matte painting, the geometry and the projection camera together. Okay, as I said, this is the scanline renderer and we'll come back to this in a second. Okay, I'm just going to tab to come back to my scene and just bring my nodes back into focus, and we can see this this node graph here that I've just been going through. These are basically nodes that I've already drawn down. I will just quickly show where to find these nodes. So in this particular case this is a 2D node, this is a checkerboard. We'll find it up here in the in this menu. All the rest of these nodes reside within the 3D environment or menu environment, which is here. So if we click on here for example and we come down to shader, this is where we will find our Project 3D node, which is here. Also in here we've got our camera, which we've got 2 versions of here, one that we're going to use to project and one that we're going to use to render the final sequence. And then finally we have our card, which is in the geometry section. We can see we've got some basic primitives in here, as well as some other nodes which are not specifically relevant to this demonstration. Okay. So what I'm going to do is I'm just going to select all those nodes, Control C, and then I'm just going to come across here somewhere, click into space and Control V, just so that we have copies of these for assembling our camera projection. And I will disconnect my viewer so that we can set up. Okay. So we're going to start with our Project 3D node. As I said, this is what brings them together. We can see that we've got 2 inputs and we've got 1 output arising from this shader node. Okay, so the way that we operate this is that our matte painting comes in to the shader via that pipe, and then we tell it what will be used to project this, which in this case is going to be our projection camera. Okay, so this is currently showing the projection of our matte painting via this projection camera. If we quickly slip into 3D, we can see not very much really. We can just see our camera existing within space. Okay. Now, as I said, there is an output from this shader, and this is where our geometry goes. So we're taking this information from our shader, we're taking the matte painting and the camera that will be used to project that matte painting, and we're telling it now to project onto this piece of geometry. So if we hook up now, we can see our geometry, which in this case is this card, and we can see this card is a little bit bigger than my projection image. We can see, if I just back off a little bit, we can see that my card here is actually residing within world space 0, within space here. If I just click into the parameters of the card, we can see here in the properties that we're set right in world space 0. Our camera, in this particular case, if we look at the attributes, we can see that I've just backed it off a little bit on the Z-axis, just to basically frame the matte painting on the card. And we can see that if I scrub the timeline, the projection camera is absolutely static. Okay, so now I need to make a copy of my scanline renderer, and then I need to put it into my scene. Now the scanline renderer is basically a node which allows us to see a 3D environment like this within the 2D world. So to connect this up, what we do is that we connect the object or scene. In this case, we're just connecting an object. We connect that up, and then we have a camera port, which is the shot camera. So essentially, what we're going to use, and scanline renderers always need a camera. The camera acts as the eye, effectively, for the scanline renderer. So this is basically how the image will be presented to the viewing audience. So this is what will be seen. So this node is where we would set up our animations, for example, if we wanted to move this camera, as we do in this particular case. If I just scrub that, we can see the camera push. And also any other optical effects that we wanted to create or animate to make the shot cinematic. Okay, so this is what the shot camera is serving. So this is a completely different role in this setup to the projection camera. The projection camera is just sat there projecting texture onto geometry. Okay, so let's just hook up the scanline to the viewer to the scanline renderer now, and we'll just switch over to the 2D view and play this sequence out. You can see it's going a little bit slowly because it's caching the file, but we can see the evidence of the image. We can see that the camera starts off sort of zoomed quite a bit out, or should I say positioned quite a bit out on Z space. It then pushes forward, and as it pushes forward, eventually the matte painting fills the screen, and we actually go in a little bit further than just a full screen into this matte painting. So if we imagine that this is Hogwarts in the distance, then we're obviously zooming in almost to the point where we can actually go in through one of the windows. Okay, so that's the premise of it. And if we go back to 3D, we can see the camera movement. We can see this is the, if I just double click the shot camera so we can see it highlighted. In fact, I'll just click out so that we only have one node highlighted. And as I push through there, we can see the camera starting out quite at a distance, and we can see from its camera frustum that we can see that the matte painting is actually quite small within the frame. We can see that as it pushes in round about at this point here, which is where it intersects with the projection camera, we can see it's now filled the screen, and then it actually pushes beyond that into an extreme close-up. Okay, so that is the basic premise of it. So when I said earlier on that the projection camera could be derived from the shot camera, we could for example see that on this particular frame here at frame 70, we could make a copy of our shot camera at that particular frame, and then make sure that we delete any animation that we have on our camera at the time, and that's a good way to create, and one of the common ways that we create projection cameras where the camera is actually moving along the path of the matte painting. Before I wrap up, I just wanted to draw your attention to this on the scanline renderer, which is a third input pipe, which is the background pipe. This is basically used if we want our scanline renderer to output at a different resolution or aspect ratio to what we have in our project settings. If I just come over here and type S, we can see that my project settings I'm currently set to this resolution and aspect ratio. We can see that I've got a whole bunch of other formats. If I wanted this scanline renderer to render something different to what I have in my project settings, then I would basically set that up here. I would create a reformat node, for example, and change the resolution or aspect ratio at that point, and then that would overwrite what we have in our project settings. It's not necessary in this particular case, but it's worth you knowing about that. Okay, I created this backdrop node earlier on, which I can now drop my nodes into, and I've got a nice tidy script. Okay, so this is the basic setup of the projection elements in Nuke. And I hope that you found it both informative and useful.